Hi, my name is Grant and I'm a system engineer from the CloudEndure service team. For many of our customers, CloudEndure brings peace of mind knowing that they are protecting their critical servers from unexpected disasters. The CloudEndure product has earned our customers' trust over time and does its job really well. Today, I'm going to talk about a new product which we have developed, which is a natural byproduct of CloudEndure Disaster Recovery. Something that our customers have expressed a desire for is a broader overview of the state of their disaster readiness. For smaller customers who are protecting tens of machines, the CloudEndure console works perfectly fine to quickly get an idea of how ready you are for a disaster event. When you start to scale upward to the hundreds or even thousands of machines being protected, it really becomes difficult to track what is happening within the environment. How many machines are being protected? How many of them are fully replicated? How many of them have been tested to ensure that they'll actually run in the new environment? These are just some of the questions we should be asking ourselves about our readiness to recover. So what is CloudEndure Disaster Recovery Factory actually achieving? To start with, the CloudEndure console is very granular with its detail. You get great information for each and every machine, but when you want to take a step back to gain a 10,000-foot overview, for example, you realize that this is not part of CloudEndure's purview. CloudEndure Disaster Recovery Factory utilizes the CloudEndure REST APIs to gather the necessary data from CloudEndure Disaster Recovery in order to build a clearer, higher overview of your state of readiness. The factory is designed to work with a single CloudEndure account. Once the data is collected, it presents it using interactive graphical elements which allow you to drill between account level and project level, and potentially other self-defining filtering levels, such as application stacks. Included in the factory is a full analysis of all your blueprints in order to be able to generate a complete overview of what EC2 resources you are going to require to recover from a disaster. The CloudEndure Disaster Recovery Factory is a step towards gaining broader business intelligence regarding your CloudEndure disaster recovery environment. With the CloudEndure Disaster Recovery Factory, you are going to gain visibility into replication health and testing, as well as visibility into the AWS EC2 resource requirements that would be needed to perform a recovery. This is going to be useful to a multitude of people, but really, it is going to be useful for anyone who is involved in ensuring that your disaster recovery planning is functioning. This might be C-level executives looking for overall reporting, managers looking to get actionable reporting, administrators who are looking to identify and action anomalies as rapidly as possible, and many others. An interesting one that we found was simply to provide evidence to your auditors that your DR plan is being tested regularly. All of these people, plus more, are going to see value in this tool. The CloudEndure Disaster Recovery Factory is a simple AWS native solution which resides entirely in your AWS account. It is deployed with a single CloudFormation template, which creates the relevant resources for the factory. The factory is going to leverage proven AWS technologies, including AWS Lambda, Amazon CloudWatch Events, AWS Secrets Manager, AWS Systems Manager, Amazon S3, IAM, and Amazon QuickSight. From this simple architecture diagram, we can get an idea of how the solution works. From the end user perspective, the only interaction is going to be with Amazon QuickSight, our business intelligence service. The rest of the solution operates automatically in the background. The whole solution is focused around a single Lambda function, which is responsible for the data collection, parsing, and delivery to QuickSight. It is triggered by a CloudWatch event scheduled expression for rules. The Lambda functions will then connect to AWS Secrets Manager, looking for a particular secret, which contains a CloudEndure API token. To ensure the integrity of the token, the secret is protected with a resource policy that only allows the Lambda function to access the secret. Not even your account administrators will have access to the secret. The Lambda function then uses the retrieved API token to authenticate against the CloudEndure service and creates a session in memory. It makes a series of CloudEndure API calls to retrieve the required data it needs. It passes the retrieved data and generates a CSV file. This CSV file is then pushed to an S3 bucket which was created during the CloudFormation setup process. The bucket details are kept in AWS Systems Manager parameters store parameters, so that the Lambda function knows which bucket to store the data in and what prefix to store it under. Once the CSV is uploaded, it deletes the local copy of the CSV and disconnects the session with CloudEndure. Finally, it triggers QuickSight to ingest the data from the S3 bucket. From the architecture, you can see that the solution is actually simple by nature. Getting it deployed is even simpler. It merely requires the deployment of a single AWS CloudFormation template as long as you have met the prerequisites for deployment. The main prerequisites which I want to cover here are as follows. The CloudEndure API token. This is an important part of the tool. The API token is linked to a given user within your CloudEndure account. As a result, we recommend using an API token belonging to an administrative user in the account, as a non-administrator may not have visibility to all of the projects. The QuickSight user is a really important prerequisite. In order to use this solution, you will need an Amazon QuickSight Enterprise Edition subscription. Without the Enterprise subscription, the deployment will fail due to limitations imparted on the Standard Edition. We also recommend that you deploy in your Amazon QuickSight home region, especially if you are a new QuickSight user, so that you can take advantage of the 1 GB free space capacity. I'm now going to step through a deployment of the solution to demonstrate how easy it is to deploy. I'll start off by opening the CloudFormation console in my browser, and then click on the Create Stack option. I'm going to be using an Amazon S3 URL, which contains our global deployment template. I then click Next to be presented with some fields to fill out. The first thing I'm going to do is to give the stack a name. For the purposes of this demo, I'm going to call it grant cedrf-demo-stack. I'm then going to work through some of the parameters that we need to fill in. The first one is an S3 bucket name, which is where the Lambda function will store the data and QuickSight will retrieve it. I'm going to give the bucket name grant cedrf-demo-bucket, all lowercase, as that is a requirement from S3 for bucket names. It is important to use a unique bucket name, and you cannot use an existing bucket for this tool. The bucket must be created by the CloudFormation template in order for us to ensure the relevant permissions are in place. The second parameter is the prefix, which I want to store the latest CSV file under. It is important that the prefix has a value, as we only want to process a single CSV at a time. I will simply use the default, which is current. The next field is a CloudEndure API token, which we already covered earlier. The next is the frequency at which we want the Lambda function to run. This is in essence the interval for the CloudWatch event scheduled expressions rules. Next up is a parameter to decide what to do with the contents of the S3 bucket if you were to delete the stack. The default is to delete the contents as well as the bucket, but you may wish to keep the data, and thus this parameter informs us how to manage this process during a stack deletion. The next parameter is the KMS key on field. By default, the S3 bucket is going to be encrypted either with the default AES 256 S3 key, or you can specify your own customer managed key via KMS. I'm not going to set anything here and use the default of AES 256. The next parameter is really important. It is the details for the QuickSight user who will own the QuickSight dashboard that is created. This must be an administrative user. Furthermore, the value in the parameter must be the full on of this user. If you do not supply a valid on, deployment will fail due to being unable to create the dashboard and assign it to a valid user. For more details on how to actually get the full on, you can see our documentation. Finally, we reach the retention period. This is just a setting to apply to the S3 bucket as to how old the files are before they are automatically removed. This will help avoid the bucket filling up with historical data that you feel you may not need. The default is set to 30 days. Once you have filled in all the parameters, you can click Next and then click Next again. This brings you to the last page where you will have to acknowledge the creation of IAM-related resources before clicking Create Stack. At this point, we would need to wait for 3 to 5 minutes whilst the stack performs its deployment. For your sake, I'm going to skip the waiting bit and come back to you when the stack is deployed. And I'm back. The stack is deployed, and it's finally time for us to see the CloudEndure Disaster Recovery interface for the first time. To get to the interface, I'm going to go to Amazon QuickSight from the AWS console. I have not deployed in my Amazon QuickSight home region, so I need to redirect QuickSight to the region I did deploy into, which is the US West 2 region or US West Oregon. From here, I'm going to browse to the dashboards, and here I should see a dashboard titled CloudEndure. I click on this to open our newly deployed dashboard. Wait a few moments for this to load up. From this dashboard, there are elements that will immediately start to jump out at you. The first thing that should stand out is the greens and reds. We have color-coded it deliberately where green is good and red is not. This way, your attention can be drawn to problem areas very quickly. From here, I'm going to quickly run over each component that you see on your screen. Right at the top, you will see 2 drop-down menus labeled Project and Application Name. These can be used to filter the graph to specific subsets of data. Below that, we have the data collection time. This simply shows you how stale the data is. It should be no older than your data collection frequency. If you notice that the data is older than that, then it might be worth checking the Lambda logs to check that the function is still being invoked, and also check to see if there's any failure during its invocation. Below the data collection time, we have a simple display of how many machines there are in the account and how many of those machines are currently in CDP. It also shows you a percentage of these machines, as not everyone wants to do the math in their head. To the right, we have 2 pie charts. These charts are showing the overall replication status and testing status of all the machines across the account. You can see in my scenario, I have a large number of machines in CDP, but I also have some in an unknown status, which could indicate that they have never started to replicate. There are also some who are shown with failed connection, some in lag, and others in initial sync. The second pie chart shows the testing data. In this account, only a very small number of machines have ever been tested, and that is very recently as well. This is important for a disaster recovery scenario, as we need to ensure that our systems are actually going to come up as expected when performing a recovery from an event. Below the pie charts, we have a heat map. The color coding indicates projects that have CDP issues. Again, green is good, red is bad, and orange means that attention is needed. You can also drill down into a given project to get more details. Below the heat map is 2 bar graphs, which summarize the replication and testing status on a per project basis. This is similar to the drill down data you would see in the heat map above. These 2 graphs allow for rapid visual alerting of projects with potential problems. Below these 2 graphs is where we start to generate actionable data. We have 2 tables with lists of machines that are affected in one of 2 ways. The first table lists machines that are potential RPO violations. This means that they are either not replicating at all due to connection problems, or they have a lag of more than 1 hour. The lag value can be customized to suit your business needs, but I'm not going to jump into that right now, as it's not within the scope of what I want to cover today. The list includes the reason for the potential violation, along with any supporting data. The second table lists machines that have never been tested or were last tested more than 1 year ago. Again, this can be customized as well, but is not within scope of today's demo. Both tables support the ability to export the data to an Excel spreadsheet or CSV file, which you can then pass on to the relevant people to get the problem areas addressed. So this first sheet has been about the replication health and testing status of your CloudEndure sources. We're now going to shift to the recovery resource analysis sheet. The focus on the resource analysis is to identify your AWS EC2 requirements on a regional and project level. This is very useful for when you want to ensure that your EC2 limits, for example, won't be breached during a recovery event. It allows you to ensure that there's going to be enough capacity provision in terms of the limits. The drill down of the analysis goes as far as identifying each EBS volume type, its total usage in terms of storage, throughput, and IOPS, where applicable, obviously, and then categorizing this on a per instance type basis. Again, this table can be exported to Excel or CSV file, which is great data to have in case you wish to do something like calculate the total AWS EC2 cost of recovery. From here, you should be able to clearly see the possible benefits that the CloudEndure Disaster Recovery Factory could bring to your organization. It's at this point that I'm going to call time on this demonstration. I could dive into various possibilities and scenarios as well as customizations that you can achieve with the factory, but I think it's best to let you play with the tool and discover your own favorite bits. Have a fantastic remainder of your day, and I look forward to hearing your experiences of the CloudEndure Disaster Recovery Factory.